Hello all aspirants, this is Praveen Kumar Sinha presenting today a topic, a decade of using open source GIS, desktop GIS and database GIS. I have extensively used OpenJump, PostGIS over PostgreSQL besides the logos on GISs on the screen. I will utilize this opportunity to introduce the aspirants with some of the beginners exercises on OpenJump and PostGIS. This is the launched screen of OpenJump. Let us open a layer and try to digitize some of the geometries. So one layer is created. This layer is shown in red letters, and that means this layer is editable. Here any feature can be digitized, otherwise right click and see that this is editable. Against editable, the check mark is there unchecked to close the editing work. So let us start inputting some geometries. So this is to digitize the point feature. This is to digitize line feature, node, vertex, 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 and at the end of the double click to come out of the tool, and node is developed at the endpoints. This is a start node, this is an end node. In between vertex, wherever I clicked, it has developed a vertex. And this tool is to digitize polygon, and this tool is to digitize rectangles. Other tools are there to do the editing work. Move vertex. So this is a vertex. You can move it if it is selected. Node can be a node. Suppose I moved from one place to another. If a node is on the line, it can be moved. Similarly, vertex point can be removed. So it has taken the stator course. Insert the vertex. So on this selected line, you can insert a vertex point. Insert a vertex point. Similarly, at the intersection, have another line passing through this line without any node at an intersection. So at this point I don't have intersection. I can develop an intersection. Select this tool. So this intersection node is developed. Sometimes there may be a need to cut the polygon. So you have this tool. Click here, and when the polygon is selected, develop the cut mark like this. Double click to come out of the tool, and so polygon is cut into two pieces. There is a tool to rotate the line. So let us suppose this is a line, and you have to rotate this line for some purpose or the other. You have that option too. You take this tool and rotate it whichever way, clockwise or anti-clockwise, it will get rotated. So this is a deselection tool. So when wider tools, wide number of tools are there to edit with very ease. Now I am removing this layer to do another exercise, that is exercise on digitization. So for that purpose I will be inserting an image map outlines. So image outline is in place. I will be creating a layer over it, new layer. So new layer is a editable layer. I will be selecting this layer where digitization work will be carried out, and then I will select a tool to digitize it. I will be digitizing it by line. So I will digitize the lines. If a straighter section is there, I will be not clicking here and there at the turning point of the straighter segments. I will be developing one vertex at each turning point, and at the end of or closer of the polygon I will be little beyond the cross of the line or polygon's corner, and double click to come out of the tool. So this line is a digitize, another line is this line, little outer, so I am overshooting the area. I am digitizing very crudely. Use yourself digitize with enlargement, panning meticulously to represent the actual feature. So wherever intersections were there, I am overshooting and digitize in that way. Double click to come out of the tool. So digitization is over. Check whether the digitization is all right or not. So remove the image from background. Yes, overshoots are there. And now we will be polygonizing the line digitize feature. So I will be going to the layer, select the feature, select a current layer item, and then go to tools and edit geometry, convert them in by the tool of polygonize. Yes, this operation is taking place on a new layer, and use selected features only. Yes, we have selected all the features of the layer to take part in polygonization and develop node on all intersection. So check these boxes and okay. So polygonization has taken place. The feature is digitize, remove the, see, these are the dangles which were overshoots, and now these overshoots are removed and only the boundaries are there and polygons are there. Now the purpose of the other layers are over. We can remove these layers by selecting them and remove selected layers. So they are removed, only polygon layer is now on the screen. When we see that the coordinates of this polygon or the whole area which is digitized, they are not georeferenced. So we georeference this. For that purpose, we will be generating a layer with georeference key entered values. I will be developing a layer, and on this layer add a new feature. The feature which will be developed is say polygon. Start bracket. Will be going to add a new feature, just pasting the formatting it to see that whether they are in the correct format or not. So see polygon double quote longitude latitude pairs These pairs are separated by comma, and at the end of the syntax double quote, it ends with a double quote, again another polygon. So this is a duplicative text format of the geometry polygon. This is formatted and OK it. So one layer is created, and see, zoom to extent, two polygons are created. The layer which we have digitized has to occupy this frame. This frame is in a geographic coordinate system, so that digitized layer has to be adjusted here. Warping the polygons, I will be invoking warp tool, and warping of the layer, new polygon will be carried out. Make this layer editable and zoom to the layer. Take this tool, this is to draw warping vector. So this corner will go to this layers, this corner, again this corner. So two tie lines are completed. At least we should have 4 tie lines to warp the layer, this corner. So 4 tie lines are completed. Editable layer is there, so warp it. Now that digitized layer is warped to the georeference location. Tie lines have warping vectors have done its job, so we can remove now. This is now let it be there, and new polygon it has done. So now how to attribute, we are switching to the another exercise, how to attribute the digitized feature. So select the layer which is warped, make it editable, go to its schema, view and edit a schema, and add field ID will be integer. Another field, say this is a lithological map, so what is the lithology, what are the lithology here? This will be string type of data, and apply changes, close it. This tool has served its purpose, close it. Go to tool, edit attribute, assign attribute, first ID field to all the polygons with auto increment type of data. It will start from 1 and increment by increment of 1, it will populate the field. So it is populated. You can label it with the ID, labels, enable labeling by ID field. Okay, so all the polygons are now labeled. Now we have to populate the polygon by lithologies of these polygons. So select this, either this way we can populate. Say in the lithology field, I have a value A, enter, close it, enter, or other way is to select the polygon, involved polygons. 2 polygons are selected. These polygons are having same values. So go to edit attribute, assign attribute, selected features, and place of a ID, lithology field to be assigned new values, assign a fixed value, yes, assign a fixed value. So they are lithology B, okay, so they are lithology B. Similarly, lithology C, hold with the shift button, select the other polygon, and they are C. Edit attribute, assign attribute, they are C, K. Rest of the polygons are polygon D, lithology D, assign attribute, polygon lithologically deep lithology, okay. So deep lithology is also digitized. Now we have all to symbolize these lithologies. Go to select here lithology and okay. Lithologically the digitized layer is symbolized. When two layers with polygon or line features are in juxtaposed sheets, there happen to be mismatch, sudden break, or discontinuity at or offset at the common boundary of the sheets. Such features are treated for their disposition at a common edge. This practice is called edge matching. The boundary of this polygon is at offset, so we have to correct it. This is a perfect map. We have digitized this, so we will be moving this. So make this layer. Edit boundary of this polygon is at offset. This is editable, so select this involved polygons at this vertex point or node and snap this to the nearest node in other layer. Similarly this side, and the job is done. This is matched, this is already matched, okay. So some snapping has taken place at this place, so now perfect match work is there. So now between these two layers, see that the attributes are all right. So we will be copying the symbology from this layer, the style of this layer, copy it and paste it here. Style, paste style. It is stating that mismatch of the field is there. So let us check with what name. This is here ID and lithology fields are there. Here make it editable. See that what are the fields here in schema. Yes, this is ID and lithology is in small letters, so make it capital letter. And a string type. Apply these changes and see that now it accepts the paste style or not. Yes, it has accepted. So both the layers are now styled. Now we have to do another exercise. To map join the layers, first check that all the layers have same definitions for their attributes, that is the nomenclature, data type, character width, and sequence of the fields. If all the layers satisfy this condition, make the layers selectable. With the selection tool, draw a box enveloping all the features of different layers. Right-click with the selection tool. In white area of the display device, go to Other Tools and replicate selected features. This will create a new layer with features of all the layers. This is map join. This is the new layer for created map join. Dissolve is an exercise carried out in a polygon layer where this is expected that there are some values common across any boundary of polygons. Here the two layer features are map joined. The dissolve operation is being carried out with the expectation that the common boundary between the two topo sheets will dissolve. The operation also dissolves the common boundaries across the fault line in a northern sheet. The tool for dissolve is available with the tools analysis dissolve. The operation of dissolve will prompt to indicate a field over which the system will carry out the dissolve operation. For current exercise, we will supply lithology field by checking the box. The return layer will have this user field only, not the others. Doing that exercise, this is a geometry related exercise, or this is an analysis related exercise. So first we will have to select the objects of the layer, select analysis, dissolve by lithology, because lithology is the common across the boundary. So new layer is created. This is the dissolve layer. Copy the style from this layer. It is a general practice to save the new layers created by users to save them in a shapefile format. This file format is an interchange vector GIS format. Directly saving the shapefile format OpenJump's results saving of the tables comprised of user assigned values to the features and system recorded spatial envelope and feature geometries, but save from OpenJump screen does not program to save the projection file. The projection file is compared to the label of the graph plots where earth dimensions and units of measurement is recorded. In absence of the projection extension file, there is every chance to confuse you with other spatial data files in the aspect that with that coordinate system your file were saved. When this shapefile has the tag of a projection file, system automatically reads and automatically understands the specifics. But this is not the drawback of software. As a matter of fact, OpenJump is designed as an front end of the PostGIS over a robust platform of PostGIS RDBMS. In the coming video section, we will see how to assign spatial reference ID to layers, establish a connection with the PostGIS database, saving the layers in PostGIS, and how to obtain the projected shapefile from the PostGIS. Keeping your data in RDBMS means your valuable data has extra protection over pilferage. To save it in a native way, I will go to the layer, right click, save as. I will select the format. So this is a ESRI shapefile and save into a directory, local directory. Okay, yes, so this is saved in the local directory. In this exercise, I will define its spatial reference ID, establish a connection to PostGIS, and write the data in PostGIS. Right click the layer, save dataset as PostGIS table legacy. Click this plus button to establish the connection. Connection manager is opened. Add new connection. Name of the connection, connect PostGIS. Driver PostGIS. Server localhost port 5433. Database PostGIS. User Postgres and password. This is very important. Whenever we will be opening our data, we will be opening with password. This may be saved, this connection parameter may be saved with the software, but if required, we may close this connection manager. So I am supplying my password and OK to establish the connection. Yes, the connection is all right, connected. Okay, yes, connection is on the line. I am going to save dissolve lithology by this name. I have selected the option radio button create a new or replace existing table. So if with the same name a file exists, it will overwrite and OK it. The file is saved in PostGIS, but I have not defined its SRID, which is important. Then only the system will recognize it as an spatial data. Otherwise, it is just a plot. So for this layer, I will be switching to next exercise, how to define the SRID, spatial reference ID. So I will selecting the layer, go to layer menu and set SRID. At present, because not defined, it is 0. We are replacing this 0 with geographic coordinate system on WGS 84 with code 43226. 4326 is the spatial reference system, which is a geographic coordinate system, not projected coordinate system. So now it is defined with this parameter. I am again saving to PostGIS, save dataset as. Here one suffix I add 4326, means with the geographic coordinate system on WGS 84. I am saving this file. Okay, this layer is saved with geographic coordinate system. Now see whether this software can transform the data to geographic coordinate system to other coordinate system or not. So this has a tool which is coordinate transformation. This is transformation tool. Here I will be defining its target coordinate system 326, and it will fall in not 44 zone 44, it will fall in 42 zone 42, UTM zone 42, universal transverse Mercator projection. With this transformation, SRID has changed to 32642. With this SRID, I am going to save it in PostGIS, save dataset as. Now this is not 4326, this is 32644. With this parameter, I am going to save as name is different than earlier. It will save as separate file. Now we will see the development in PostGIS. Closing this window. PostGIS is a library of GIS utilities and valuable methods to operate upon the user's spatial data on a simple structured query language or SQL, which has a hardly 6 or 7 commands as simple as a simple English sentences, but with a strict rules. Script languages go on changing, but the overall frame of SQL will not change. These syntaxes in batch lines can minute treatments over geometric coordinate as well as the user attributes saved in tables. Besides the protection of your data in Postgres RDBMS, you have double advantage of using the syntax of the Postgres and module extra functionalities of a PostGIS on applicable on the geometry object to get return of complex logical, relational, conditional statements on spatial tables. PostGIS saves vector and raster data. This is a PG admin graphic tool for Postgres. Here we have a local host and we have to enter into the local host, which is a server, local server on this system. So we will like to connect it. One password is desired. I have to pass one password. This server informs that there are 6 databases on this server. I will be clicking on this node. I have to go to PostGIS where our data is saved. So this is the node for PostGIS. This PostGIS has 3 schemas. I have saved my data into public schema, and there are 27 tables with this schema. These are different implementation methods and which works with the PostGIS database management system. And you can see that there are 892 functions of a PostGIS. So dissolve related 3 tables are saved, which were these 3 are the latest one without projection, another with 326442, and a dissolve lithology 4326. So let us open 4326 and make a query over the dissolve lithology. So right click, scripts, selection script. So here the selection script has come for all the tables, all the columns of the table on dissolve lithology 4326. If I run, it will show the result. So it has 2 fields. One is the ID field, other is a lithology field, and beside these 2 fields there is a geometry field. If I ask transform my geometry, st transform this geometry to from 4326 to 32642, and see the result, very similar result. The geometry location has changed, but geometry is informed in hex decimal values, so we are not able to identify it. But if I take this formula or this syntax to OpenJump and make a query, database query, file run data store query. So here I may have already established connection parameter file. So I have taken that file, and my PostGIS is now connected, and I am issuing this select command and okaying it. A new layer is created, and which is projected. You can see the values in a lower right corner, that values are projected UTM value on 32622. These are not geographic coordinate system of SRID 4326. So this is the output on output of PostGIS to OpenJump, and whereas saving the data or acquiring the shapefile from PostGIS is this tool. So this tool has import and as well as export tool. I can directly take this shapefile into PostGIS, and from PostGIS I can export my data. Yes, with this connection parameter, let it be connected. Connection successful. Add tables. System is now showing a table. I am selecting this table, which is a geographical coordinates in a geographical coordinate system, and okaying to give me this data saved on my desktop with projection file. And now export it where I want to save it, on Telangana University folder with shape files. Name here 4326 is not there, extension file is not there. I am saving here. Sorry, it was asking for folder shape. Create a folder, maybe PostGIS folder, and open. So here system informs that the table export is completed. Closing it and going to desktop university shape folder. I created a PostGIS. Here I have the 4326 shapefile with PRJ file. This is the look of the PRJ file, which is a tag to the geometry or the coordinate system in which our data exists. In OpenJump, I can take this data as well, open PostGIS. So this is that layer which has coordinate system as GCS. So it is not projected. I have to zoom extend it to. Now you can see on the lower right corner, it is in geographic coordinate system. So closing this exercise. Initially, OpenJump was developed as front-end GIS over PostGIS, but now it has sextant libraries to operate upon raster data as well. Here is the sextant development which has raster capabilities. These are the different tools which can be utilized for our analysis purpose with rasters, and vector tools are also there. In conclusion, I have to state that in last 15 years, I have an opportunity to vigorously handle the tools of OpenJump with PostGIS in my major projects and modeling. It has lot of capabilities and it is open to you all. Thank you very much. Thanks.